Hi, Professor Kaplan here. I'm a retired college professor. I taught economics and applied math at both the undergraduate and graduate levels here in New York for about 20 years. And today, what we're going to do is we're going to find the equation of a line given 2 points, or given a point, and I should change this to 1 point. Given 1 point and the slope of a line. So let's see what I'm talking about here. So let's take a look at the graph real quick, and let's take a look at a point 3, 2, and m is how we refer to the slope. So m is equal to 2/3. So 3, 2, we can call this 3, we can call this 2. So here's a point, and we want the equation of a line through that point with the slope of 2/3. So it would be a line something like this. Okay? So let's see how we go about that. We know we have point slope form, which is y minus y sub 1 is equal to m times x minus x sub 1. And we're going to use that to our benefit here. So here's x sub 1, and here's y sub 1, and here's our slope. So let's see what happens here. We have y minus 2 is equal to the slope, which is 2/3, times x minus x sub 1, so it's x minus 3. So we have y minus 2 is equal to, we're going to expand this on the right side, distribute the 2/3, 2/3 x minus, well, when we go to multiply 2/3 times 3, the 3's cancel and we're left with 2. So now we're going to add 2 to each side, and we get y is equal to 2/3 x minus 2 plus 2. So y is equal to 2/3 x. That's the equation of our line. Y is equal to 2/3 x. Here's the line. The equation of that line is y equals 2/3 x. Okay, let's take a look at another example. So, how about -6, -2, and the slope equal to 2? So we've got, let's see, -6, -2, we've got something, let's say a point here, with the slope equal to 2, so it's going to be a positive slope. So this line is going to go up to the right. So let's see what we have. We have y minus y sub 1 is equal to m, which is the slope, times x minus x sub 1. So let's start filling this in. We have y minus -2 is equal to 2 times x minus, let's do that, x minus -6. So let's rewrite this and eliminate the minus sign. So we have y plus 2 is equal to 2 times x plus 6. I strongly urge you to burn that extra step and write out the -6 with parentheses, and then distribute the minus sign in each case. So now we can expand all of this. Y plus 2 is equal to 2x plus 12. We're going to subtract 2 from each side. Y is equal to 2x plus 12 minus 2. So y is equal to 2x plus 10. That's the equation of the line, and let's look at the graph of this thing. It's going to cut the y-axis. Remember, when we do this, 2 is the slope, 10 is the y-intercept, y is the dependent variable, and x is the independent variable. And y is the dependent variable because it depends on the value of x. So we can always predict y with 100% certainty given a value for x. And we often say that x is the exogenous variable and y is the endogenous variable. X is determined outside of the model. That's what exogenous means. And y is determined inside the model. That's what the endogenous part means. So this is also an exogenous variable, and this is an endogenous variable. So 10 is the y-intercept, so it's going to cut it up there. So this is going to look like so. We have y is equal to 2x plus 10. So that's what this graph looks like. It's a line that intercepts the y-axis at 10, or I should say 0, 10, and has a slope of 2. If we want to know what this point is, where it intercepts the x-axis, we can simply set x equal to 0 and solve. So y is equal to 2 times 0 plus, sorry, we set y equal to 0. Way to go, Charlie. 0 is equal to 2x plus 10. So 2x equals negative 10, so x equals negative 5. So this point here, it cuts the x-axis at negative 5. All right? And it's as easy as that. Let's take a look at another example here. Let's see what we can do. How about negative 3, 4, and the slope is equal to negative 3. Okay, so we're starting here. Y minus y sub 1 is equal to m times x minus x sub 1. So y minus 4 is equal to negative 3 times x minus negative 3. So y minus 4 is equal to negative 3 times x plus 3. So y minus 4 is equal to negative 3 x minus 9. Now we're going to add 4 to each side. Y is equal to negative 3x, and then negative 9 plus 4 is negative 5. So there's the equation of the line through this point. Now let's take a look at the graph of this thing, okay? First this is the y-intercept is negative 5, right? That's this value right here. Now let's set this equation equal to 0 and solve for x. So 0 is equal to negative 3x minus 5. Negative 3x equals 5. So x equals negative 5/3. I hope. Yep. So we now have 2 points on this graph. Negative 5/3, x is equal to negative, that's 1 2/3. So let's see what gives here. We have the y-intercept equal to negative 5. Let's call that there, that point. And the x-intercept negative 1 2/3 or negative 5/3. Let's say that's here. So this line is going to look something like so. And we'll label our line y equals negative 3x minus 5. So this point is negative 5/3, and this point is negative 5. Those are the two important points on this graph. Nobody cares what any of these points are or these points. They care about 2 points, that point and that point, the x and y intercepts respectively, and the slope of the line. Those are the 3 important factors that we consider when we're graphing a line. So, okay, let's take a look at another problem. How about, let's see, how about negative 2/6 and the slope equal to negative 5/2. Okay, so y minus y sub 1 is equal to m times x minus x sub 1. So y minus 6 is equal to negative 5/2 times, let's do that, x minus negative 2. So y minus 6 is equal to negative 5/2 times x plus 2. Now we can distribute. Y minus 6 is equal to negative 5/2 x minus, and these 2's cancel, minus 5. Let's add 6 to each side. Y is equal to negative 5/2 x. And we have minus 6 plus 5 is plus 1. So there's the equation of a line that goes through this point, 2, 6, and has a slope equal to negative 5/2. Now, we want to graph this, so let's find the x-intercept. So 0 is equal to negative 5/2 x plus 1. 5/2 x equals 1. We're going to add 5/2 to each side. So 5x equals 2, and x equals 2/5. We divide through by 5. So the x-intercept, 2/5 x is equal to, is 0.4. So that gives us an idea of what's going on here. So the y-intercept is 1, and the x-intercept is 0.4. Call it about there. And let's draw a line. Let's label the line. Y equals negative 5 halves x plus 1. So that's how we do it. We have a negatively sloped line, negative 5 halves. So we would be doing, say, down 5 and over 2, down 5 and over 2. We have our two intercepts, 1 and 2/5 or 0.4. And that's pretty much everything here. Okay, let's take a look at two more, and we'll call it a day. So how about 4 negative 5 with a slope equal to negative 2. So y minus y naught is equal to m times x minus x naught. Oh, I've been using y sub 1 and x sub 1. Well, changed it up a little bit. I'm using y naught and x naught in this one. Doesn't matter. So we have y minus negative 5 is equal to negative 2 times x minus 4. So we get y plus 5 is equal to negative 2x plus 8, right? We distribute the 2 throughout, negative 2x plus 8. And now we're going to subtract 5 from each side. So we get y is equal to negative 2x plus 8 minus 5 is plus 3. So there's our equation of the line that goes through the point 4, negative 5 with a slope of negative 2. Now we're going to graph it, so we need the x-intercept. So we're going to set this equation equal to 0, negative 2x plus 3. We'll add 2x to each side, and we get 2x is equal to 3, so x is equal to 3 halves, which is 1.5. So now that we have the two intercepts and the slope, or the two intercepts, we can graph this thing. So the y-intercept, which is right there, plus 3. So the y-intercept is 3. And the x-intercept is 1.5. Let's draw our line. Look at this, I can't even draw a straight line. I am probably the worst artist on this world, on this planet. Okay, so this is y equals negative 2x plus 3. And that goes through the point 4, negative 5. So this would be approximately 4, negative 5. So that's the equation of a line that goes through 4, negative 5 with a slope of negative 2. It has two intercepts. The y-intercept is 3. The x-intercept is 3 halves, or 1.5. We're good to go. And let's take a look at one last problem. 6, negative 2 with a slope equal to 4. All right, so we have y minus y naught is equal to m times x minus x naught. So y minus negative 2 is equal to 4 times x minus 6. So y plus 2 is equal to 4x minus 24. So now we're going to subtract 2 from each side. Y is equal to 4x. We have minus 24 minus 2 is minus 26. So there's the equation of the line that goes through the point 6, negative 2, and has a slope of 4. We're going to graph this, so we need the x-intercept. So we're going to set our equation of the line equal to 0. 0 is equal to 4x minus 26. So add 26 to each side, we get 4x equals 26. X equals 26 over 4, and that's equal to 6 and 2/4. So x is equal to 6.5. 26/4 or 13 halves. Okay, now we're going to graph this. Let's see what it looks like. Well, we have our two intercepts. We have the y-intercept over here, which is negative 26. Let's say that's right here. And we have our x-intercept at 6.5. So let's call that here. So there's our line. Let's label the line, which is y is equal to 4x minus 26. And so y equals 4x minus 26 is the equation of a line that goes through the point 6, negative 2, and has a slope of 4. It has our intercepts at x equals 6.5 and y equals negative 26. And that's about it. That's what I have for you today. Once again, this is Charles Kaplan, retired professor, taught economics and applied math at the undergraduate and graduate levels for about 20 years. Please subscribe to my videos if you found this helpful. I hope you found this helpful, and I really hope you have a great day. And that's all, folks. Bye-bye.